The last point I'm going to make is related to the first problem, and this also applies to the other problems where the box could possibly move vertically. On the first problem, where you've got an object on a horizontal surface, all of the same rules apply. The first thing we need to know is, does it move? Well, in order to answer that, we need to compare the maximum static friction force to, well, in this case, since it's not on a slope, it's not a component of the weight that is pulling it down the hill. There happens to be some external force. In the case of the first problem, it's 20 newtons. So any motion that occurs here is going to be in this direction. So in order to determine whether it moves, we need to compare the forces that exist in this direction. In this case, we've got 20 newtons pushing it to the right, and because there is some friction, there's going to be a friction force pushing it to the left. So the structure is the same, but the specific force we plug in is different. To answer whether it moves, we now have to compare this 20 Newton force to the maximum possible static friction force, which is found the same way. 20 newtons is as fundamental as it gets. That's a given number, but this friction static max is, again, mu static times the normal force. Where in this case, again, since it's not on a slope, the normal force and the weight are going to be equal because there's no angle between them. So that makes life pretty easy in the y direction. The sum of the forces in the y direction are 0. That tells us that the normal force equals the weight being mg. Normal force is equal to mg. So the first question you need to answer for numbers 1, 2, 3, 4, and 5 is, does it move? If you find that the answer is no, you're done right there. But if you find that the friction static max is less than whatever force is trying to get it to move, then you need to start going into the forces in the x direction to figure out exactly what the acceleration is. Good luck!